Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about tangent lines.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, y equals x to the third power minus 3x squared plus 2, and we need to find the equation of the line tangent to the function at 3, 2. So what we first want to do is actually find our derivative here. So we want to find, let's call it f prime of x. And we're going to use the power rule. 3 comes down, x, subtract the exponent by 2, or by 1 to be 2. Minus 2 comes down, multiply it by 3, we get a 6x to the first power, and then the constant derivative is 0. So at this point, we have our derivative, so we want to find the slope of the tangent line there, right there at 3, 2. Our x value is 3. So we put 3, f prime of 3, and let's put 3 in for x. 3 squared minus 6 times 3. Well, 3 squared times 3 is 27, and 6 times 3 is an 18. We subtract them right here. 27 minus 18 gives us a 9, and that is actually our m value, the slope there, at x equals 3. Well, the process now is just like we normally do with the equation of a line. We have our slope. We need to use our y equals mx plus b form. So we use the coordinate point and the slope. 2 in for y equals our slope 9 times the x value, which is a 3, plus b. And now we're solving for b. 9 times 3 gives us that 27 plus b, we have 2. Subtract 27 to both sides, and b equals a negative 25. Well, we have our m value, our b value, so we can write the equation of line. Y equals a 9x minus 25, and that's the equation of our tangent line, all right, our line tangent to the function at 3, 2, and again, that's our final answer. We're given this problem right here, y equals a negative 5 divided by x squared plus 1, and we want to find the equation of line tangent to the function at negative 1, negative 5 halves. Well, first thing is I want to find the derivative of our function, and like to do that, I like to rewrite this to be negative 5 times x squared plus 1 to the negative 1 power. Okay, that's just my preference of how to write this function. I just find it's easier to take the derivative this way. Let's go find f prime of x, y prime, however you want to put it. Negative 5 stays out front. Break down the exponent, negative 1. We're using the chain rule here. X squared plus 1, all to the negative 2 power now. Multiply it by the inside, x squared becomes a 2x. We have our derivative. Let's go simplify this out a little bit. F prime of x is equal to, well, multiply across the numerator. Negative 5 times negative 1 is a positive 5, times a 2x is a 10x. Over our denominator, we'll bring down the x squared plus 1, and instead of a negative exponent, it's a positive. It's positive 2. So we have our derivative here, and what we want to do now is plug in our negative 1, our x value, in for this to find the slope at that x value. So we have f prime of negative 1 here is equal to 10 times a negative 1 over negative 1 squared plus 1 all squared. What does that come out to be? Well, 10 times negative 1 is a negative 10. Pretty easy. Denominator, negative 1 squared is 1, plus 1 is 2, right? Square that, we have a 4. That simplifies to be a negative 5 halves, and that's our slope value, our m value. Well, we need it in y equals mx plus b form, slope-intercept form, so we need to find our b value, and we use a coordinate point for that. So our form says our y value, negative 5 halves, is equal to our slope, negative 5 halves again, interesting, times our x value, negative 1, plus b. Well, negative times a negative is a positive, right? And 1 doesn't really do anything. Negative 5 halves equals a positive 5 halves plus b. Subtract a 5 halves to both sides, and we get a negative 10 halves, which simplifies to be a negative 5. So we have our b value, our m value. We can write the equation of the line. Y equals a negative 5 halves x plus, or subtract actually. Let's write subtract instead of plus and negative. I do like writing plus and negative a lot. Minus 5 here. And so the equation of our line that's tangent to the function at negative 1, negative 5 halves is y equals negative 5 halves x minus 5. We're given this problem right here, y equals x to the third power minus 2x squared plus 2, and we want to find the equation of the line tangent to the function at 2, 2. Well, the first thing I like to do is find the derivative of our function. Let's call it f prime of x, and it's equal to, power rule, 3x squared, minus 2 times 2 is a 4, 4x, subtract the exponents by 1, which is a 1, and the derivative of 2 is 0. So our derivative is pretty easy here to find, but we want to find the slope there. Well, the slope, we take our x value, which is at 2, and plug it in for x. F prime, or x in our derivative, to clarify. 3 times a 2 squared minus 4 times a 2. From here, we're solving, right? 2 squared is 4 times a 3, comes out to be a 12, and 4 times 2 is an 8. 12 minus 8 gives us a 4, and so our derivative here at 2 is 4, which is equal to our slope. Well, now we want to find our b value. So we use our formula y equals mx plus b. 2 is in for y, is equal to our slope, 4 times our x value, which is 2 again, plus b. 4 times 2 is 8, plus b. Subtract an 8 to both sides, and b is a negative 6. So we have a negative 6 for b. Our slope is 4, so we can write this together to be y equals 4x minus 6. And right there is the equation of the line tangent to the function at 2, 2, and again it's y equals 4x minus 6. We're given this problem right here. Y equals a negative 3 over x squared minus 25, and we want to find the equation of the line tangent to the function at negative 4, 1/3. Well, first thing is I'm trying to find the derivative of our function, and I like to rearrange our function to make it easier for me. Negative 3 here, and then instead of dividing by x squared minus 25, I write an x squared minus 25 being multiplied with the negative 1 power. And that's just a personal preference on how I like to take the derivative. So we're going to find f prime of x, let's call it. Negative 3 stays out front, but then our power comes down, negative 1. Keep the inside, x squared minus 25. But then the exponent, we subtract by 1, minus 2. Multiply that by the derivative of the inside, which is 2x. Let's go simplify this out a little bit, f prime of x here. And negative 3 times the negative 1 is a positive 3, times 2x is a 6x. And that's going to be over our denominator, x squared minus 25. But again, instead of a negative exponent, we have a positive 1 if we put it in the denominator. And 2 there. And now we have a derivative. So let's go find the slope of the tangent line there. We need to plug negative 4 in for x. So we find f prime of negative 4. And we have 6 times a negative 4 over negative 4 squared minus 25 all squared. And let's go simplify that here. Okay, 6 times negative 4 is a negative 24 here. And how far did I go? Negative 4 squared minus 25 comes out to be a negative 9. And then we have to square that. 16 minus 25 is negative 9. And then we square that. Negative 24 here over negative 9 squared is a positive 81. And this fraction simplifies to be, for my notes here, negative 8 over 27. And so that here is our slope. We need to find the b value. So our formula tells us we have to use y equals mx plus b. So we have a y value of 1/3 here is equal to our slope, negative 8 over 27, times the x value, which is negative 4, plus b. And now we're solving for b. Okay, 1/3 stays here. Negative 8 over 27 times the negative 4 is a positive 32 over 27. And I did the work for you here. 1/3 minus a 32 over 27 is a negative 23 over a 27. So we have our slope, we have our y-intercept, we can write the equation of the line. Y equals a negative 8 over 27 x minus 23 over 27 is where the line is tangent to the function at our coordinate point negative 4, 1, 3. So again, this is right here our final answer. We're given this problem right here. Y equals a negative 3 over x squared minus 4, and we need to find the equation of the line tangent to the function at 1, 1. First thing I like to do is, I know I'm going to take the derivative here, but I like to rewrite my function like this. Negative 3 times the x squared minus 4 to the negative 1 power. And that's just a preference of mine on how I like to take the derivative. So now let's take the derivative. F prime of x, let's call it, negative 3, and we bring down the negative 1 power, x squared minus 4, subtract the exponent by 1, negative 2. Multiply that by the derivative of the inside, which is a 2x. Not too bad. Keep on going here. Let's go simplify this derivative here. Negative 3 times the negative 1 times the 2x is a positive 6x. We have 6x here. Denominator stays to be that x squared, or we bring down this part, x squared minus 4, and we raise that to a positive 2 power because now it's back in the denominator. Either way, we have our derivative, 6x over x squared minus 4 all squared. We now want to find the slope of our tangent line. To do that, we take our derivative, f prime, and instead of x, we plug in our x value at x equals 1. Let's go find that slope. 6 times a 1 here over 1 squared minus 4 all squared. From there, we're solving for the slope. We have 6 over 1 squared is a 1 minus 4 is a negative 3. How far did I go here? I left it like this, negative 3 all squared. Keep going. We have 6 over negative 3 squared is a positive 9. And 6 over 9 simplifies to be 2/3. That's equal to our slope. Well, we have our slope now. We just have to find the y-intercept. Again, this is just algebra at this point. We use our formula for y equals mx plus b. Our y value is 1, equals our slope 2/3, times our x value, which is 1, plus b. Well, 1 times 2/3 is 2/3, so we have 1 equals 2/3 plus b. Subtract the 2/3 to both sides, and we have a 1/3 here. And so our b value is 1/3, our m value is 2/3, and so our equation of our line here is y equals a 2/3 x plus a 1/3, and that is where it is the equation of line tangent to the function at 1, 1, and it is our final answer. We're given this problem right here. Y equals a 5x plus 5 to the 1/2 power, and we need to find the equation of the line tangent to this function at 4, 5. First thing I want to do is find the derivative, f prime of x. Well, I'm going to use my power rule here. 1/2 comes out front, and I keep 5x plus 5 on the inside, and again I'm using the chain rule as well. Exponent is subtracted by 1, negative 1/2. We multiply that by the derivative of the inside, which is, well, just a 5. From here now we can write this as a fraction, bring it back, or bring it to a fraction. The numerator is just 1 times 5 is a 5. 2 comes down here in the denominator with the 1/2. And a negative 1/2 power can go to the denominator being a positive 1/2 power, which is the same as the square root. So we have the square root of a 5x plus 5 here. Now that we have our derivative, we can use this to find the slope of the tangent line at our x value, which is 4. So we have to plug that in, f prime of 4, plug that in for our x value, and we have 5 over 2 times the square root of 5 times a 4, plus 5. Now let's keep simplifying or solving. 5 over 2, the inside, 5 times 4 is 20, plus 5 is a 25. 5 over, well, 2 times the square root of 25 is 5. And, well, the 5's kind of cancel here, and we have a 1/2. Okay, or you can multiply it out and simplify the fraction. Either way, our slope here is a 1/2. With that information, we know our formula, y equals mx plus b. Let's go find the b value. It's just algebra at this point. So we have our y value, which is 5, plus our, equal to, not plus, it's getting silly me, equals our slope, 1/2, times our x value, which is 4, plus b. Solving for b, 5 equals 1/2 times 4 is a 2, plus b. Subtract 2 to both sides, and b equals 3. Well, we have our slope, we have our y-intercept, so we can combine them together to be y equals a 1/2 x plus a 3, and that is the equation of the line tangent to our function at 4, 5. We're given this problem right here. Y equals the natural log of a negative x, and we need to find the equation of the line tangent to this function at negative 2 comma natural log of 2. Well, first thing I want to do is find the derivative of our function. Let's call it f prime of x. And the derivative of a natural log of u is u prime over u. So the derivative of the inside of negative x is a negative 1 over the inside, which is a negative x. Well, get rid of the negatives, and f prime of x here is just a 1 over x. Pretty simple there. From there, we want to find the slope of the tangent line at this point. We take our x value here and plug it into our derivative. So we have f, we'll put it here, f prime of negative 2 is equal to 1 over negative 2. Pretty easy here. And we have, well, a negative 1/2 when we see it like that. And that is our slope. Well, our equation says we have to find the b value for y equals mx plus b. And so we use our coordinate point. Our y value is the natural log of 2. Don't be afraid of it. Is equal to our slope, negative 1/2 here, times the x value, which is a negative 2, plus b. Same rules still apply. Natural log of 2 stays here. Don't rush to your calculator to get a decimal. Negative 1/2 times the negative 2, all right, is a positive 1. We have positive 1 here plus b. Subtract 1 to both sides, and b equals a natural log of 2 minus 1. Don't be afraid of that b value. You don't need to just get a decimal. Let's leave it as it is. So we can combine our slope and our y-intercept to get the equation of line. Y equals a negative 1/2 x plus the natural log of 2 minus 1 being our b value, and that is the slope of the equation of the line tangent to the function at our coordinate point, negative 2 comma natural log of 2. And again, the final answer is y equals negative 1/2 x plus natural log of 2 minus 1. We're given this problem right here. Y equals a negative 2 tangent of x, and we need to find the equation of line tangent to this function at negative pi comma 0. First thing I need to do is find the derivative of our function. Let's call it f prime of x. And what is that equal to? Well, negative 2 can just stay out front here. We're multiplying that by the derivative of tangent x is secant squared x. Secant squared x here. Well, we have our derivative, and we want to find, well, the slope of the tangent line at our x value, negative pi. So to do that, we take our derivative, f prime, and we're going to put a negative pi in for x here. Negative 2 times secant squared of a negative pi. Well, secant squared of a negative pi is a 1. So we have negative 2 times a 1, and negative 2 times 1 is a negative 2. And that's our slope right there, a negative 2. But we also have to find our b value, y equals mx plus b. So we use our coordinate point here, 0 for the y, is equal to our slope, negative 2 times the x value, negative pi, plus b. And now we have to solve for b. Well, 0 equals negative 2 times the negative pi is a positive 2 pi, plus b, and subtract the 2 pi to both sides, and b equals negative 2 pi. Again, don't rush to the calculator, but this is a decimal. It's nice and neat this way. We have our b value, we have our m value, y-intercept and slope. We have y equals our slope, negative 2, negative 2x. Kind of have the variable there, negative 2x minus a 2 pi, and that is the equation of the line tangent to the function at negative pi comma 0, and again, our final answer. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.